Now,
Yes, sir.
Yes, sir.
Yes, sir.
okay, we already finished half of the fourth module, that is the timers and counters. The second half of the fourth module is serial communication. Before going to enter into the serial communication, just we'll discuss what is a communication. Can anyone please tell me what is communication?
Flow of information between two places, sir.
Okay, it is the process of sharing an information from one place to another place. What exactly that place? From source to destination, we are going to share the information. We are going to share the information from one point to another point. That we can call it as a communication. We have different types of communication. That is two types of communication: wire communication and wireless communication. Wireless communication examples, if I am going to take a best example is your cell phones. It's a wireless communication. And also we have a satellite communication is also there, mobile communication is also there, wire communication. So many techniques we are going to adopt to transmit a signal from one place to another place, that we can take it as different types of cables. What we are going to use your dish cable, that is coaxial cables, and optical fiber cables we are going to use to transmit or sharing an information from one place to another place. We are going to use we are going to be, previously we are going to use coaxial cables. After that, in the advanced technologies, we are going to use an optical fiber cables. The advantage, what we are going to use optical fibers, we are going to transmit a light. We are going to transmit a information in terms of light we are going to use. That is why it's an advanced technology compared to your coaxial cables, what we are going to use in the olden days. Okay, the principle working under this optical fibers is total internal reflection, that is TIR. You are familiar with these topics, total internal reflection. In the physics you might have studied about these basic things about your total internal reflection. These are some of the different communications. Here we are going to use a computer communication. Okay, human communication is different. Computer communication is different. Communication means we are going to share a data from one place to another place. Means from one system to another system we are going to transmit a data. For example, I am going to take an example of your microcontroller lab. Why? Because we are going to study about microcontroller subject. We are going to deal with this serial communication or parallel communication. Two types of communication we have, that is serial communication as well as parallel communication. Okay, in the advanced technologies we are going to use some techniques called UART, universal asynchronous receiver transmitter. Okay, that is a serial communication, very important concept we are going to use in the communication. For example, if you are going to study a MATLAB, microcontroller laboratory, in the part B we are going to use some of the kit. Some of the kit, hardware kit we are going to use. How you are going to transmit a data from your system to that kit? We are going to use some RS-232 cables. RS-232 cables we are going to use to transmit your data from computer to that particular. ನಾನು ಬೇಕೆ where I was about to tell about your RS-232 cable. Okay. For example, if I'm going to write some of the codes in my system, I cannot transfer that program to a kit wireless. Okay, I need to use one wire, that is RS-232 cable I need to use. Through that cable, I'm going to send that program to that kit. In that kit, we have a 8051 microcontroller chip we are going to dump that program to that chip by make use of your RS-232 cable. That data we are going to transmit, either it may be serial or it may be the parallel. That we can discuss later, how exactly we are going to transmit the signals from one system to your hardware kit. Okay, that is the major introduction based on your communication. Okay, with respect to that, here we are going to use preferably serial communication. We are going to transmit a serial data. Why? Because here we are going to deal with a digital numbers, ones and zeros. At a time we cannot transmit those things. It will be some complications we are going to face. That is why we are going to use some serial data communication. Serially, we are going to transmit a data. Okay. Then with respect to that, here computer transfer data in two ways, that is parallel as well as a serial data we are going to use. In that parallel, what we are going to take, often 8 or more lines, see the parallel diagram. First diagram shows the parallel transfer, okay, from 0 to 7, D0 to D7 data bits, what we are going to transmit from source to sender to receiver or source to destination. We are going to transmit a bit. Okay, so now I need to transfer 10101010 at a time. I need to transfer. We are going for a parallel communication, parallel data communication. We are going to use here 8 or more lines. We are going to use wire conductors are used to transfer data to a device that is only a few feet away. Means it's a some minimum distance we are going to use this type of communication. Okay, what we are going to here, not only from D0 to D7, if you want you can take D0 to D15, like that we can extend. It's 8 bit, 16 bit, 32 bit, like that we can extend the bits and we can transmit a data from source to the destination. That is about your parallel communication. We are a lot of problems we are going to face when we are going to use parallel communication, because with respect to our laboratory, we are going to use some of the experimental results we need to get, so that we are going to use some serial data communication to transfer to a device located many meters away. A serial method is used. The data is sent one bit at a time. Means here show that a sender here initially if you want to transmit a data one bit, that is your logic 0 or logic 1, once we can transmit. Again after that we can transmit a second bit. Okay, but in the case of parallel at a time 8 bits we can transmit, but in the serial data transfer we are going to transmit only one bit at a time. One bit at a time we are going to transfer. Okay, please make a note of this diagram, both parallel transfer and serial transfer diagram, and make a note of this theory. Next we'll go for next slide. Or okay, next coming to the in serial communication, we are going to at the transmitting end, the byte of a data must be converted into a serial bits using Parallel in, serial out, shift register. Okay, we have different types of shift register, that is parallel in, serial out, and serial in, parallel out, serial in, serial out, and parallel in, parallel out. Four different types of shift registers we have, as you studied in the logic design or DSDV lab, where we have already studied about your shift registers. Here, how we are convenient, as our convenient, we are going to a conversion, we are going to converting a parallel input to the serial output, we are going to convert, means we are going to get a serial data. For example, parallel 1111 parallel 1010 parallel data we have, that we are going to convert it into a serial data. The serial data will be one after the other, we are going to transmit. At the receiving end, there is a serial in, parallel out shift register, we are going to receive the serial data and pick them into byte of a data, serial in, parallel out. Then again we are going to convert that serial data into a parallel data. Why we need to convert this parallel into serial? Why? Because our serial communication, it will be it's the name only indicates that we need to transmit a serial data. That is why we are going to convert parallel data into a serial data, we are going to convert. Then again we are going to store with the parallel data. That is why anyhow we got the receiving end, we got the a serial data, that we are going to convert it back into a parallel data, so that we for the further this one we are going to use for this parallel data. When the distance is short, the digital signal can be transferred as it is on the simple wire and requires no modulation. For example, if I am going to communicate with a lower distance, for example, I need to transmit with respect to that computer communication, I will take an example of LAN, okay, local area network. Local area network means the systems what we are going to connect in a single room, it is having a wired connection. We can share a data from one system to another system. But if I am going to take a metropolitan area network, I need to transfer my data from this location to some other location. Either it may be other state or it may be other country. I need to transfer. I need to get a wireless communication. It will be over a long distance. If I need to transmit my data to the over a long distance, I need to go for a other communication techniques. We need to use some modulation techniques, so that we can transmit data from over a long distance. That is the major difference with respect to computer network with a local area network. Means within a room we can transmit a data by make use of wire and wire connection we can use. If we need to transmit a data over a long distance, we are going to use for the other techniques. We are going to use some transmitting transfer techniques it requires modulation techniques are required. Okay, if the data is to be transferred in the telephone line, it must be converted from zeros and ones to the audio tones. For example, how we need to convert ones and zeros by make use of telephone. For example, I need to transmit a voice signal to one place to another place. I'm going to use a telephone network. I'm going to use to transmit my voice. Initially, voice cannot be transmitted directly. Why? Because it's an electrical signal. Because of ones and zeros we need to convert, we are going to use for transducers. I'm going to convert my voice signal to an non-electrical signal. That will be from either it will be digital signal. I'm going to convert. How exactly I'm going to convert my analog signal to a digital signal? Analog signals are continuous with respect to the time. It will be like sinusoidal signal. It will be keep on varying with respect to the time. Okay, so that I'm going to make first. It's having some block diagram to convert analog to digital signal. Okay, first initially I'm going to make a samples. I'm going to take a sampling theorem. I'm going to apply for the given signal. I'm going to divide these samples with respect to the samples. I'm going to divide by make use of a sampling theorem. Next, I'm going to use the quantization. I'm going to set the levels of quantization. Either it may be 0 voltage, or it may be 1 volts, or it may be 2 volts. I'm going to map the amplitude of that voltage. I'm going to differentiate with respect to the quantization. Quantizer I'm going to use. Different types of quantizations we have, mid-riser and mid-trend quantizers we have. Those things are you are studied. You will be studied in communication subject. What we are going to get it in the next semester for principles of communication system or digital communication. There you are going to discuss a very clear picture about your communication. What exactly the quantization, what exactly the sample and hold circuit, how exactly we are going to convert analog signal to equivalent of digital signal. That we can convert it into an analog signal to ones and zeros from the audio tone. We are going to transmit that with respect to the system with the serial communication. This conversion is performed by a device called modem, modulator or demodulator. Modulation modem we are going to use to transmit the data. Modem means it's a modulator or demodulator. Okay, make a note of these things, important points. Go on. We'll move to next slide.
Yes, sir.
Yes, sir.
Okay, here we are going to discuss about the serial data communication. Uses two methods, that is synchronous method transfer of block of data at a time, and asynchronous method transfer of a single byte at a time we are going to transmit. What exactly the meaning of synchronous and asynchronous that we can discuss. It is possible to write a software to use either of these methods, but the program can be we are going to use with respect to the UART, what I have told, Universal Asynchronous Receiver Transmitter, USRT, Universal Synchronous Asynchronous Receiver Transmitter. First one is preferably first technique we are going to use to transmit our serial data. First one is very, very important. We are going to use UART to transmit the data, serial data from one place to the another place. Especially when we are going to deal with the chip, what we are going to use 8051 microcontroller chip. In that we are going to dump the data by make use of system. We are going to use this technique only, universal asynchronous receiver transmitter. Why? Because for this we are going to use RS-232 cable. That is very convenient to transfer the data from one place to another place. That is why we are going to use with this universal asynchronous receiver transmitter. And USART, Universal Synchronous Asynchronous Receiver Transmitter, it is having both synchronous as well as asynchronous data we are going to transfer. It will be used for the multiple users. Okay, make a note of this. Okay, we'll come to next one. See here. This is a simplex transmission. How exactly we are going to use half duplex, full duplex, and simplex. If data can be transmitted and received, it's a duplex transmission. In the duplex, we have different types. That is, first one, data transmitted one way at a time. It is transferred to as a half duplex. We are going to call it as a half duplex. See here, this is a transmitter and receiver, and here also transmitter and receiver. We can transmit, and it will be going to receive with a receiver. Again, we have another channel to transmit from another side. It will be going to receive. That is, we can call it as a half duplex. Once if I am going to transmit with the first channel, the second channel will not be work. Second channel will not be work. If I am going to receive or transmitting a data from second channel, it will be working only second channel. Only one channel, or it will be at a time. It will be working. That is why we can call it as a. See, here we have a two different data we can transmit. We can receive two different data, but at a time one we can transmit and one we can receive. That we can call it as a half duplex. Then what is a full duplex? Full duplex, okay, it is with respect to the transmitter. We can one side we can transmit the data, and another side we can receive the data. Two-way channel we are going to get the information from source to destination. That is, we can call it as a full duplex. And what is the simplex? It's a only one way. One way we are going to transmit a data. Okay, we are going to transmit with respect to only one way. There is no receiving. That we can call it as a simplex. Okay, this is the difference between simplex, half duplex, and full duplex. Make a note of this. Can you write the examples for simplex, half duplex and full duplex? What is the example for simplex? Have you remembered pager? In the olden days, pagers are used for military purpose. Just we are going to receive the data. We cannot transmit that. Full duplex is your cell phones. Half
Sir,
duplex.
even ringtone.
Sorry?
Ringtone is also used, no, sir, as simplex transmission.
Yeah,
Data
yeah.
is only received and it's getting counted.
Then tell me example for half duplex and full duplex. Next we'll discuss about
Okay,
protocols,
sir.
how we are going to discuss. Sorry? Yeah, tell me. Answer attendance. Abashri,
Present, sir.
Adarsha,
Present, sir.
Ajit Kumar,
Present, sir.
Akshita,
Present, sir. Present, sir.
Amutavalli,
Present, sir.
Ananya, Asha, Ashok,
Present, sir.
Smaran,
Present, sir.
Basuraj,
Present, sir.
Bharat,
Present, sir.
Srikari,
Present, sir.
Ashrita, Sivanarayanappa, Rohit Kalyan, Chandan,
Present, sir.
Ahalya,
Present, sir.
Chetan, Chetan, yes. Dikshit, Deepika,
Present, sir.
Deepti,
Present, sir.
Dhanushri,
Present, sir.
Dhanush,
Present, sir.
Vignesh Reddy,
Present, sir.
Krishna Rohit,
Present, sir.
Manish, Meghana,
Present, sir.
Hamsa,
Present, sir.
Harsha, Rutik, Jason,
Present, sir. Rutik, present, sir.
Javeria Taj,
Present, sir.
Jitesh,
Present, sir.
Venkata Sai Prithvi,
Present, sir.
Prasad Reddy,
Present, sir.
Kavya,
Present, sir.
Kirtana,
Present, sir.
Uday Kumar Reddy,
Present, sir.
Kushala,
Present, sir.
Layana,
Present, sir.
M. Charan.
Present, sir.
Okay. Thank you. We'll continue in the next class.
ಸರ್ ದೀಕ್ಷಿತ್ ಪ್ರಶಾಂತ್ ಸರ್.
ನೀನು ಅಲ್ಲಿ ಮೊಬೈಲ್ ಆನ್ ಮಾಡಿ ಇಟ್ಬಿಟ್ಟು ಅಲ್ಲಿ ಹೋಗ್ಬಿಡು.
ಹಾ ಸರ್ ಎಲ್ಲೂ ಹೋಗಿಲ್ಲ ಸರ್.
Sir, Rutik, present, sir.
ನಾನು ಕೇಳಿದಾಗ ಯಾರ್ಯಾರು ಪ್ರೆಸೆಂಟ್ ಹೇಳಿದ್ರೆ ಅವ್ರಿಗೆ ಮಾತ್ರ ಅಟೆಂಡೆನ್ಸು.